Hello and welcome to Cool Planet's final Masterclass series of the year, Harnessing Data for Energy Efficiency. Now, my name is Dean Brown, but joining us today is Diana Ignatiuk, Customer Success Lead here in Cool Planet, but has over 6 years of extensive engineering experience in production processes and continuous improvement. Now, joining Diana today will be Abhinav Agastya. Before joining Cool Planet, Abhinav worked as a marine operations engineer on board cargo ships and oil tankers for over 6 years. Together they have a wealth of knowledge, but today they will specifically touch on strategies to identify maintenance issues early through data analysis, methods to apply statistical tools to your data for performance predictions, and finally insights on selecting the ideal platform to simplify data review and summarisation. So as always, if you have any questions or queries after the masterclass, please don't hesitate to get in contact. But without further ado, enjoy the show.
Thank you for joining us today. I'm Diana Ignatiuk, Customer Success Lead at Cool Planet, and today here we have Abhi.
Good morning, Diana. Thank you so much for joining me. Today, my name is Abhinav Agastya, and I am the Customer Success Manager here at Cool Planet. Today, Diana, we are going to discuss about how we can harness data for energy efficiency within the industries that we work with. It's a very interesting situation for us to be in as customer success managers, where we discuss about how we can optimize the process and improve upon the data, how we can use the data to improve the processes within the industry.
Exactly. I think we are in such a good place because we work with so many customers from so many industries, and we are exposed to all the different equipment that they are using. And what I found more often than not is that 75% of the problems that one group of customers identify applies to all the other industries. And we are in a really good place to see all the different pieces of equipment that they are using, because that gives us more insight into what opportunities we can identify, what the majority of the deviations are, and how we can improve those deviations.
So let us touch upon the subject about how we are able to derive value for our customers through the data analytics that we are doing on Cool Planet OS.
What I think it is really important to identify the moment that the issues start appearing. What happens more often than not is that there is this piece of equipment in general, boilers, compressor, and refrigeration, that sits somewhere in the back of the production system. All eyes are on the production process, and the moment that a hiccup happens, this is the only time that eyes start looking at the utility systems. So the moment that an engineer, a utility manager, a maintenance engineer can identify that there is a deviation happening in the process is when there is a hiccup in the production or the production is stopped. And that can happen 3-5 months within the year, the moment that it's already too late. Deviations and energy consumption occurred all this time, money out the window, carbon emissions into the air with no action taken.
I absolutely agree. Early issue identification is the most important value that we are creating for our customers. We are finding the problems just as they occur, and this is, as they say, little drops to make a ocean. So if we are not catching those problems early on, they cascade into a huge loss, both in terms of capital and carbon emissions.
What I think is that it helps us a lot that we can benchmark pieces of equipment. An easiest way that we do that is by creating the KPI, the performance of this piece of equipment. And the moment that we see, hey, the performance or the COP of this equipment is between these ranges, then we know that is good performance, bad performance. And the fact that we have access to so many industries, to so many pieces of equipment, that gives us a really good leverage in helping our customers.
Yeah, that's absolutely correct. Uh, why don't we go into a few of the techniques that we use for identifying these issues, just like we did in the compressor analysis for one of our customers, where they had a sharp drop in one of the KPIs and we detected a leakage. Let us go through that. So here, Dana, we had a customer where they were using compressors, one of their most energy intensive equipment in the plant. What we did was using data from their production facility and from their compressor volumetric delivers and energy consumed. We created KPIs of volume produced per kilowatt hour of energy consumed, and the kilowatt hour of energy consumed per ton of production. And these KPIs were essential for us to find out how we could detect a leakage in the system. As we can see, there was a sharp drop in the HP system KPI, and this helped us to find out the leakage early on and get it rectified, as we can see, within 12 days. And this was essential in saving the costs for the company as well.
I can see that it's quite easy to see the fact that the HP system leaked into the low pressure system. So this is where the efficiency of the full compressed air system dropped. That's quite interesting.
Yeah. This kind of early detection is something that is valuable for our customers, and it can be done easily on the Cool Planet operating system. At the end, I think it's not only essential that we find out when the KPI is dropping, it is also crucial that we do real time monitoring. What do you feel about that,
I
Diana?
agree.
Yeah.
It's exactly as I said in the beginning, the fact that it's so late that it happens that we identify deviations within the compressor system or refrigeration system or the boiler system. What it's really useful is to identify instantly whenever the deviation happens, because at that moment we can take immediate action. We don't need to wait 5 months to get more energy poured into the system, because we can take then and there action to either improve the control, either remediate the problem that we have identified.
Yeah, that's absolutely correct. One of the other value generation that we do for our customers is performance prediction. How do you think that analyzing data and using that for benchmarking performance?
This is something that our customers keep asking us more and more. The majority of areas that we get the more requests are main e-commerce, gas and electricity, but it's more and more the fact that our customers want to understand how the production system is impacting the utility equipment.
Yes.
And how is the utility equipment performing based on the production needs and demands.
Yes, I agree. And using this data, we are able to derive key insights both in the terms by using statistical tools and models, where we are doing regression analysis for our customers and trying to predict the energy consumption of machineries based on ambient conditions, production data, and various other sources. This gives us a benchmark where we are able to see if there is any drop in the performance in the machinery. Suppose there is a compressor that is not performing according to its needs, we have theoretically predicted how it should be performing and how it is not performing now.
One of the things or areas where we are helping our customers with prediction models is as well estimating how much energy they will be consuming based on whatever they have in store in terms of production. So this helps them better estimate how much energy that they will need in the next month, so they can forecast the budget to identify if they are able to produce within the available budget or if they will be exceeding that. So we all know the fact that energy prices skyrocketed and is more and more pressure on the production environment to be efficient. And at that moment, yes, it is really interesting and important that we start looking at this utility equipment. The moment that the energy price started increasing, people's eyes started focusing more on the utility equipment. What are our compressors doing, refrigeration and boilers? And in general, aside from the production environment, this is where the majority of energy is being consumed, and our customers just didn't have the expertise. These models get them better equipped with managing their utility equipment. They know better now what actions they can make to improve the efficiency of the systems so that there are less hiccups, less maintenance cost, less idle time, at better efficiency and support for the production environment.
Yes, this is a huge tool in their arsenal for production plants where they can basically predicting the future needs and trying to justify whatever budget that they are want to be approved. And as you said, the energy prices are going up. They can also buy energy beforehand, and they can accurately predict how much they would require. Yes, as we can see here, we have created a model for the refrigeration plant, and as we can see, it is across 12 months. It has shown a deviation of just around 2.9%, which is an amazing feat
So
for
that is basically the strength of the energy model that we
models.
have created in the
Yeah,
refrigeration. That's
yeah.
so interesting.
This model is based basically on the production data and the ambient condition, and that's it. Another aspect of performance prediction is also deviating from their usual performance, and this is another case study where we found out how one of the compressors was just running idly, and it was not looked on by the plant manager, and we could immediately figure that out and stop the idle running of the compressor. This is, I feel, Dana, just money running down the drain.
It is.
Yeah.
Let's discuss about this.
Yeah, absolutely. I think uh, for compressor systems, we are working with so many customers, and we see that there is a frequency where there is similar problems occurring across the entire ecosystem. And one of the biggest problem was that of idle running, where uh, the compressor is just not cutting off even when the required volumetric need for air has been achieved. And this is the lowest hanging fruit, in my opinion, where the companies should focus on and start stopping their compressors basically and reducing their energy needs.
So what it happens in general, companies will have a couple of main pieces of equipment that will be delivering utility to the production environment, be it air, cooling or heating. And there will always be one or two pieces of equipment as backup. Unfortunately, what happens is that that backup piece of equipment will charge and stop, waiting to be needed.
Yeah.
But it will not be delivering any type of utility to the production system. And that charge and stop is just consuming energy, not delivering anything. And that is just creating nonsense in the data, creating nonsense in the KPI, creating nonsense in the performance. And
Yes.
what happens whenever this equipment is just there idling on and off and on and off creates wear and tear.
Yeah.
Without any benefit to the production environment, and that is increasing maintenance cost, operation cost as well.
Yeah. Another aspect of performance prediction, Dana, I feel, is the measurement and verification that we do for our customers. And it's a huge leap ahead with using this platform. And it's that we are able to do this in real time. Could you expand on that, Dana, a bit?
So in general, we are doing measurement and verification every time that we have a project on site, and that project can be CapEx or OpEx. Our customers are always interested in seeing if the changes that they've done to the process or the equipment yields in the results that they are expecting. Now, in general, measurement and verification happens with offline data. Someone goes around the equipment and is taking manual measurements of the performance and the consumption and the outputs of that piece of equipment, and months later an MMV report, measurement and verification report, is created. What we are doing, we have the capability of using live data from the platform and instantly and constantly monitoring if the performance of the changes that we've done together with the customer are leading to the output that we are expecting. And this is done live in real time, and we can always do zoom in, zoom out to see when, where, and how the performance is deviating. And again, we can create watchers so that if performance is deviating in a way that we don't like or don't want, then we take immediate action in making a change so that the performance goes back to normal.
That's a huge leap forward, Dana, in my opinion, where we don't have to wait for the energy bills to come at the end of the every month and do the verification and measurement, and we can just do that in real time.
I agree.
Yeah. The measurement and verification, the models, what do you think are some of the key aspects in using and finding a choosing a right platform, and using data for on that platform? What do you think is the
In
right
general,
mix?
as we have been discussing here and as we have seen throughout the experience, is having a platform that gives us the ability to make any changes, any investigation that we want. So be a platform that is adaptable to my needs, a platform that is scalable. So do I have enough data to come to the right conclusion within the system that I want? So as we have been discussing about, compressed air, refrigeration, and boilers, okay, if we look at the performance of the equipment, is that giving me the right insight? Do I need to add more information like ambient condition, like process production, like other third party companies that are delivering heating or cooling to my system? We have identified that some of our customers are buying heating and cooling from third party, and they have their own heating and cooling in house. So yes, can we integrate with that data? Can we get that data of third party into the platform so that we see how is that impacting our platform or our piece of equipment, and how the different production processes and production equipment that we have available, how is that impacting our equipment? And another important thing is how easy is to bring that data over, because with offline data we have to do so much manual extraction from the different BMS systems, SCADA system, control systems, and get that into a platform that will ingest offline data. And we find more often than not that the granularity is not right, that we missed some important date range there. So it's really important to have the data there ready and to do the investigation high level, low level as well. Another important thing is be flexible. So how can we identify a tool that gives me all the different capability? If I want to see the performance as an overall KPI for last month, what if I want to see the KPI in more granular, to see by shift?
Yes. Yeah.
Or by hour? If I change my SKU, how is that impacting my KPI? Is that increasing, decreasing? Do I need to create a different target for my KPI because I'm processing this type of product instead of this type of product?
Yes.
Do I have that flexibility available on hand?
Yeah.
And the last thing is how easy it is for me to share with the people that are providing the platform if my needs are met.
Yeah.
If the platform is easy to use, if I get the right support, if I have all the tools that I need to be able to find easily the deviation, identify opportunities, close the gaps, validate if the actions that I'm taking in the process and the utility equipment is the right action.
Yes.
How easy is that communication? So as an overall, this.
Wow. What you have described is the ideal platform that would help plant managers delve into their data and extract information nuggets. I think, Diana, we should wrap up today our masterclass by I'll just point out the key takeaways that we have had discussed today. I believe the three points that could come out of this masterclass were the need and using data to find out early issue identification, performance prediction, and how choosing the right platform would be essential. For early issue identification, Dana, we discussed about what's the importance for using early issue identification and the techniques. We went a bit deep into creating meaningful KPIs and tracking them in real time, ensuring that there are checks and alarms in place to give alerts to the plant managers whenever there is an issue that is coming up. We saw a case study for the compressor. Uh, then we went into the performance prediction and how using statistical tools and models are able to create benchmarks for the machinery, and we are able to better predict what the energy needs for the plant as a whole would be in this ever changing energy intensive scenario that we have. We also discussed about how measurement and verification can now be done in real time in a more granular way, and we are able to discuss and see how our projects are performing uh, every hour, basically. And Dana, what you mentioned about choosing the right platform, about how it should be adaptable, it should be scalable, and it should be able to integrate seamlessly into the various data structures that we have currently, be it manual data entry or be it the old SCADA screens. We need to extract that data, integrate that into the platform, and then we need to play around with it. Finally, we have got the support and development that we provide uh, in helping the plant managers understand what their KPIs are, what their uh, benchmarks are, and what their energy needs would be like in the future. Uh, Unfortunately, we won't be able to answer all of your questions today, but we do have some common questions coming up. Dana, would you?
One of the most frequent question is, how do I know if my equipment is performing well or not? How do I calculate the efficiency of compressed air, the coefficient of performance? How can I monitor that?
Yes, absolutely. That's a very important question, and every plant manager needs to be aware if his equipments are performing in a right way. The best way for us to know this is by knowing how the industry in general is performing. Another way is to find out by looking at the equipment's manuals. For refrigeration purposes, what we do is look into the manual, find out what the ideal range for coefficient of performance should be. Similar values are provided in the boiler manuals as well. But what comes into the picture is to calculate that efficiency, calculate that COP in real time basis. And this is what we can do on the platform. So whenever there is a deviation, whenever we are deviating from that coefficient of performance, from that boiler efficiency, we can immediately know and take the right actions to ensure that we come back into the green zone. Yeah.
Another good thing is that we are exposed to so many industries, so we can do benchmarking between pieces of equipment. What we found out is that based on the age of the equipment, then it's performing differently. So even if, let's say, in the real estate of your industry or of the company that you're working in, you don't have your type of equipment or so many equipment to do the benchmarking, we have that available. So we'll be able to say, yes, your equipment is performing well or underperforming, and then work together with you in identifying what actions can we take to improve the efficiency of that piece of equipment. Another common question that we have is, can we do predictive models to identify if my yearly budget will be achieved or not?
Yes, I agree. We can do predictive modeling to an extent, that we can see if we are exceeding our budget, or we can also use those models to predict our next year's budget. uh, what predictive modeling essentially does is break down the budget into its major constituents. Suppose we have a budget for operating expense and it is 70 to 80% energy needs. Then we find out what the major energy needs are. We delve deeper and deeper into figuring out what the major constituents are, and then we see those constituents, what those constituents are dependent on. Suppose the major energy consumer within the plant is the refrigeration system. We see what are the key drivers that are increasing or decreasing the refrigeration system's energy consumption, and then we do the multiple regressions, the modeling, and using those models we are able to accurately predict, as we can see from the case study, the energy needs that would be met required in the future. And that's how we can see if we can meet the budget or not.
That's really
Yeah.
easy.
Yeah.
One last question that we can take at this moment is one that revolves around cost and carbon emissions. So, if I want to see, this is another frequent question that we have from our customers is, what if I want to see what is the total cost of the energy every month, so that I know in which area to focus, and in terms of emission reporting, then what tools do I have access to know if I'm able to reach my carbon target?
That's a very interesting question, Diana. I feel that costs and carbon emissions go hand in hand. If we are reducing our energy needs in this energy expensive market, we are not only reducing our costs, but we are also reducing our carbon emissions. So, this is a win win situation for our customers, where by the identifying the key energy drivers in the industry and trying to optimize that entire process, we are not only able to reduce the costs but also in turn reduce the carbon emissions. Thank you so much for joining the masterclass, and if you have any questions, please don't hesitate to reach out to us at Cool Planet.